Okay, for example 1, we're asked to consider the function f of x equals 2x squared minus 4x plus 5 and answer the following questions. The first thing it asks us is, does the graph open upward or downward? Maybe before we do that, sorry, I didn't realize that was, there we go. Maybe before we do that, we should identify what the letters A, B, and C are. So A equals 2, B equals negative 4, and C equals 5. These are going to come in handy in just a second. So for the first question, does the graph open upward or downward? If you flip back to the notes there, well, we're looking at the A value. Is it greater than 0 or is it less than 0? So in this case, our A value is greater than 0, therefore it opens upward. The axis of symmetry, we're asked to find the axis of symmetry. It's x equals the opposite of b over 2a. Plugging in those variables that we know, we got the opposite of b was negative 4 over 2 times our a value of 2. Cleaning this up a little bit, we still got that negative out front. Negative 4 over 2 times 2 is 4. So it's negative, well, it's a double negative, which means it's a positive. So we got 4 over 4, which is 1. So our final answer for that one is x equals 1. When you're giving the axis of symmetry, don't just say the axis of symmetry is 1. We got to say it's a line, x equals 1. Now for the vertex, again, the coordinates that we're using are negative b over 2a, comma, f of negative b over 2a. Well, we already know that first one. That first one is our x equals 1. So we'll say the first coordinate is 1. Now the second coordinate, we just got to take that 1 and plug it in. So we're going to do f of 1. So plugging that back into the original function, we have 2 times 1 squared minus 4 times 1 plus 5. Cleaning this up a little bit, 2 times 1 squared is 2. 4 times 1 is 4 plus 5. So 2 minus 4 is negative 2 plus 5 gives us positive 3. So our vertex is at the coordinates 1, 3. Our y-intercept, don't need to do a whole lot here. It's just the c value. It's 5. So you can go through and plug these into a calculator and double check and verify that these work. But before we do that, or actually after you do that, I'm not going to do it on video here. Let's take a look here and see if we can identify a couple things. What I'd like you to do is read through these functions, and I want you to circle the functions that are open upward and highlight, or if you don't have a highlighter, underline the functions that have a y-intercept that is less than 0. So I'm going to pause the video, circle the ones that have open downward, and then highlight and or underline the functions that you think have a y-intercept less than 0. Okay, you've clearly paused and you're back. So opening downward means it's going to have a negative a value. It's got a negative coefficient in front of the x squared term. So let's circle those. So the first one, 2x squared, that opens up, positive a value. G of x, negative 4x squared. The negative a value means it opens downward. H of x, got a positive 1/4 as your leading coefficient, so that opens upward. J of x is negative 99x squared. That opens down. It's got a negative leading coefficient. And P of x, negative x squared, that opens down because our negative leading coefficient of negative 1. For highlighting, let's take a second and talk about or find ones that have a y-intercept less than 0. So the y-intercept on f of x is negative 7, that c value. So that's going to get highlighted, or if you're not using a highlighter, underline it. G of x doesn't have a c value listed. In other words, it's plus 0. So that one is 0. So we're not going to highlight that one. H of x, 1/4 x squared plus 3x plus 100. It's got a y-intercept of 100. J of x has a y-intercept of negative 100. So we're going to include that. P of x, negative x squared minus 3. Don't get thrown off by the fact that the 3 is the second term. It's as if it were negative x squared plus 0x minus 3. So it's still your c value. So that one does have a y-intercept that is less than 0.